So now let's move on to the cabin thermal comfort workflow. So this cabin thermal comfort solution is a PowerFlow PowerTherm coupled solution, and there are a number of different ways that we can evaluate a cabin design that will be highlighted. And with this workflow, we're mostly focused on simulating harsh environments, the cabin in harsh environments. So it's either a hot environment, and we want to see how we can cool down the cabin, or a very cold environment, and we want to see how we can heat up the cabin. And while we're doing this, we're looking at the passenger comfort as well as the energy required to get to a comfortable environment and then maintain that comfortable environment. So performing these cabin thermal comfort simulations allow for the early evaluation of a cabin design through virtual prototypes before the physical prototype is available, and also for the evaluation of many different operating conditions that would be difficult to test otherwise. So this leads to a reduced cabin development time and a cost savings due to the reduced need for physical prototypes. Using the cabin thermal comfort workflow also allows us to design a cabin that improves the machine operator safety, because we are able to safely evaluate more harsh operating conditions that would be difficult to test otherwise, and we can assess the operator's comfort in those scenarios. This workflow does consist of pre and post processing templates, as well as automated simulation execution, which allows the user to conduct a complete virtual test in under a week. This is a short video shows how the simulation can be used to design comfortable and energy efficient cabins in real world conditions. So in the PowerFlow simulations, we're really looking at the airflow of the HVAC system into the cabin and how the passengers are experiencing that design. So the human comfort is a metric that we consider, and how long it takes for the humans to be comfortable. That's a key design metric, but it's not the only priority. We also want to balance the energy consumed to reach a comfortable state, because that's going to have an impact on things like the fuel efficiency or the range or the operating time of the vehicle or the machine. So this workflow diagram details a soak and cool down process, which is a common workflow for industrial equipment, since the equipment can be left outside in the sun for long periods of time. So we can also do simulations for cabin heat up or defrost scenarios where the machine or vehicle is in a cold environment. In most of these simulations, we're looking at the geometry for the cabin interior as well as the HVAC systems. And because we are wanting to calculate human comfort, we do include the humans in these simulations. However many humans are supposed to be within the cabin during operation, we want to make sure we have those available and properly postured in our model. Since we do need to have a thermal model and a fluid model,